Hello everyone, my name is Nnamdi. Welcome back to my channel. Today I want to speak about the telemetry command and its core innovation. If you look at it, the polycore telemetry command is really the backbone of data gathering and error reporting and information gathering, data gathering and information gathering, data gathering and data gathering or to get insights in data, and data reporting if there is any data on the internet that you want to report, maybe something something very special that I've been working on. The telemetry command is really a powerhouse because if you want to use it you use it you use it to gather data and insights on data and report any ambiguities in data. So that is really what it's about. um that's what the meaning of telemetry. Telemetry is data gathering and information and insights in that data, uh, in that data to model something. Maybe you want to start a business. And you start this. Let me give you a study example. Say I'll give you two examples. The first example I'll give you is a simple survey. You go to a website endpoint, and there's a server there, and then you just put in the values, and it's reported to the server. In that aspect, you get the table you can use for that. Um, Purposes. And then that's really the simplest example. It's I can't it into two uh, servers. So that and then if you get a lot of people doing a survey, you get the real-time data analytics, and that's in you get the data that's in real time. Maybe on the server end, you update that data as much people get on that service. Maybe that service is uh, uh, a simple service like that, and you want to scale it, you can get this and you can know what trends were, what will work, and you get data. You get to know how much people done that thing. It has application in something called maybe an ad service can utilize it to yes, an ad service can utilize it. You can use it as uh what is it like to hook to an ad service. Just to get at the data to see whether how the API was being used. So it's real-time analytics in action. A more broad example is like if you have a game and you have a protocol API, it's a web-based game, and you have a poll at the end. That's more so did you last match? And you know how to tell your business to that, how you want to resolve relationship if there are any in the game or game. Maybe some people request this feature, or maybe some people rage quits, or some people enjoyed it so much that so much that they played so much and invited their friends to play. So that's what telemetry gathering is all about. Now I want to speak about error handling. The telecom is very special. We have on ultimately two things now. First, two things. The first, so we're speaking about something called I call it real time telemetry. That is really the concept where we're gathering data through that's because the protocol command polls on it's about protocol. So when the protocol polls on an endpoint, and then it's a silent protocol. It's just an observer. It just observes connection between the server and the client, and that's protocol command. But the telemetry command here is really saying, okay, this endpoint here. Uh, I'm going to observe it with the protocol, and I'm going to get the data too. So it's really flexible to know how your system is being used, and that's the protocol exe telemetry command. Some problems in this domain too. There's one more thing I want to talk about, and this something about UIDs and GUIDs. Protocol has a GUID system, a global unique identifier, integrated into the protocol interface. I'm not sure how to define it yet, but that's what's coming to it, and that's it's gonna be there when it's there. It's gonna slug solid, and it can be there for everyone to see and use, exposed to the protocol exe. Let me give an example. Let me give you a concrete example. The polycall exe has the telemetry command for every voice data gathering. We have UUID, unique user identifier, for every user on our system as a colorful units. Maybe this person signed up for the service, signed up for the service. That solves the problem. But we have this global unique identifier system as part of the telemetry command for global unique identifier for anyone on any system using making calls to the Polyflow API. It's not an extension of the UUID. We didn't do that. How it's implemented? Is, let's start with UUIDs. The UUID command for Polycall is a standard UUID. If you know UUID, standard UUID implementation for unique user identifier. But my core innovation is in the GUID, the global unique identifier. We flip the script. We don't flip the script. We made it so that what the UID is, it's just grab user identity. So for session storage, everything, just use you have a user, maybe an end user, maybe authenticate them, authorize them. You get a user. The user can use that data. You know who that user is. But we have you see when you fall short of when it comes to debugging and all of that heaviness of the protocol system, I want to say that the protocol telemetry GUID is the go-to to solve this problem of debugging, configuring, maybe authentication. I invented, not me, just me and one. I'm still on my own in the business. I was it's not just too bright. It's not too bright. Okay, so I invented a new cryptography algorithm to create global unique identifiers. This is the protocol GUID under the telemetry command and submap commands. This GUID command is special in its own right, and people that care about the data really do care about the data. I mean, to the point that they're obsessed with every imperfections in data will love this command. The GUID is the global unique identifier. This is how it works. So in the old protocol system, I implemented a state machine for this version 2. Version 2 is version 1. So this version, the global unique identifier was implemented as a state machine. The state machine was mapped to a router. The router behaved like an NFA, known as a non-deterministic finite automaton, with cryptography signature checks. The idea is that, but it wasn't seeded. The idea of all of this is to standardize. So still use the protocol today, but it wasn't seeded. So, so in this old implementation of protocol version 2, version 1, not version 2, version 1, not version 2, is to have the map states to the router, a router implement the binding architecture, the binding side of the router. You see, the binding side of the router. So if you have a Python polycall, COBOL polycall, that binding side is the router that's handled by the COBOL driver code, which is the server that uses the binding architecture, the bindings as an intermediary to work with the protocol system that sends requests to the server and back and forth. Although in version 1 it works, we have the working logic to map the router and ship the bindings. Version 2 brings greater resource for the telemetry system. In the version 2, these are the core algorithms involved. Step 1. The telemetry command GUID subcommand is seeded with a random cryptography seed. This ensures that when the maps to route, you have a new cryptography generated GUID string to an API route or endpoint or even application endpoints. It doesn't matter as long as the polycall can knows how you balance your data to the binding, then you can always send it to the server and you can always get the data back. The protocol is stateless, always stateless. It doesn't care about it. It just wakes up when you type that data. When you hit the import, bam, you get the data because it just intercepts the data and hands it back like a bouncer. But here in telemetry command, the GUID it has seeded cryptography seeded. And then when you a user, say you have a bug in a program and you want to replicate it. So you want to replicate my next. When you want to replicate a bug in a real life environment, this is what the GUID producer. So the first just see GUID is seeded and it's seeded. It's a string that's seeded. It's cryptography seed that is maybe a hash. It's using a hash function that's seeded to give a cryptography signature. That signature in the router implementation, or in the core protocol implementation, is bound to an equality of state solution, like an NFA, final DFA NFA system that maps to a router in the binary system. That router, that router, that router or path endpoint to any resource book, books, 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 a bank account system, any data, a service you're offering that that handles data for users has a router class mapping to that protocol binding router that struggles into a string. For the end user, so if the end user submits a ticket system, the ticketing system says that okay, so every time the user updates and the user hits a snag or error in your system, we don't just say okay, error, we don't just throw an error. We want to know how the error occurred, what actions the user took. These are what the critical agent does is step 2, tracks every state, enumerates every state using the automaton model. And or just enumerates every state where they go back, forward, and the buttons they click. Any button they click, or any video, so it takes you to how the system was operated. So it's like a snapshot of every path. Okay, you go to books, you want to buy a book, you return a book, and then it throws it. And then if the program, if any error happens within that program, within that process, say the user returns a book, and the book return has been accepted, and then the server crashes for some unknown reason. The idea is to trace the bug where the program is, and that's global unique identifier in the protocol system comes with timestamps. Okay, and then so when there's an endpoint, when there's an endpoint to that data, the GUID string represents all the information necessary for that state of informations until collapse. We can enumerate that state too, and you rerun the program, retrace how the user program was done. It's not about it didn't just replicate the entire system to failure, and refine the system accordingly. That is exactly what the protocol command does, and the protocol telemetry command do under the GUID. So when you're using protocol, make sure to pick a algorithm. Just make sure it's a critical seeded algorithm. That doesn't use we don't use MD5 because that's been cracked. But you can use SHA-256 or the up-to-date one, SHA-3 if you like. If you have cryptography properties you want to assume, not 0, and you want to know how your data was processed. The protocol telemetry it's a significant addition to it. So I want you to take advantage of it and really debug the application. Alexa, shut up. So I really debug the application. So with that in mind, I'll hope to give you examples soon in another video. So you can see how to actually take care of it, use it in the real world, in an application system. So all that has integrity too. And you can also use so all that has integrity too. You can make sure you can see how how the path the user took. Okay, how did it get navigated to the page? Who made what call? And it gives everyone, developers, anyone in the developer team. We have our responsibilities, even though we're developers. Anyone in the team working on a polycode project with a binding architecture, to understand what what is happening in their own programs too, and how to adjust their architecture, these features or not, or how to treat errors, so to gain insights on their data, get insights on so they can get insights on everything they do and understand everything that's happening within their program from the end user too. So one thing I want to say is sometimes can you attach the ticket too? So when a user when a bug occurs like this, and it's not a feature, it's a bug. I mean literally a bug. You then create a ticket. You can create a ticket on your endpoints on your server and attach it to the GUID and UID systems. Note, you never seen it's like a session thing. You can use it for session. Unique identifier for users on your system. Unique user identifier, and GUID is just a global identifier. But you can still use GUID for the UID too. It's not really it's not really. It's not. It works because it's global seeded. So you just can use it. You can use a GID and UID. You can use it. You place a GID with GID if you feel for your needs. For your needs. Okay. Thank you for watching. Subscribe to my channel and I hope to see more people soon here. And any questions, you can message me in the comments below. Just leave them in the comments below. I'll reply to them. Okay. Thank you and goodbye for now. Take care. Subscribe to my YouTube channel.